Hello. Today we are going to discuss control techniques, and in those, the first ones are PERT and CPM. Project evaluation and review technique, as well as critical path method. Now, a few network techniques have been developed for effective planning and control of complex project works. In network analysis, a network diagram is prepared to show the interdependence between the operations of a project. It reveals gaps in the flow plan and the sequences of activities. So, the object of network analysis is to enable management to plan and control the operations for realizing project objectives economically and efficiently. Network analysis makes use of probability and linear programming as well. So, when we come to this PERT method, PERT is a method of analyzing the tasks involved in completing a given project, especially the time needed to complete each task to identify the minimum time needed to complete the total project. So we always want our projects to take minimum time so that we can reach efficiency. It incorporates uncertainty by making it possible to schedule a project while not knowing precisely the details and durations of all the activities. It is more of an event oriented technique rather than start and completion oriented, and is used more in these projects where time is the major factor rather than the cost. So it is applied on very large scale, one time, complex, non routine infrastructure and on research and development projects. PERT offers a management tool which relies on arrow and node diagrams of activities and events. Arrows represent the activities or work necessary to reach the events, or nodes that indicates each completed phase of the total project. So arrows with the activities, events with the nodes. PERT and CPM are complementary tools because CPM employs one-time estimation and one cost estimation for each activity. PERT may utilize three time estimates: optimistic, expected, and pessimistic, and no costs for each activity. Although these are distinct differences, the term PERT is applied increasingly to all critical path scheduling. Now you can see this PERT diagram I was telling you. So these arrows are activities and these nodes are your the goals, the aims. So if we go into a little history of PERT, PERT was developed primarily to simplify the planning and scheduling of large and complex projects. It was developed for the US Navy Special Project Office in 1957 to support the US Navy's Polaris nuclear submarine project. It found applications all over the industry. An early example was it was used for the 1968 Winter Olympics in Grenoble, which applied PERT from 1965 until the opening of 1968 Games. This project model was the first of its kind, a revival for scientific management founded by Frederick Taylor, that's also known as Taylorism, and later refined by Henry Fordism. So DuPont's critical path method was invented at roughly the same time as PERT. Now, if you see the process of PERT or CPM, what happens is the activities and events that should be performed to complete a program are clearly identified, that these are the activities and these are the events. Activities are represented by arrows, events are represented by the circles or the nodes. Event is the actual performance of a task at a given point of time, while an activity represents time and resources for progressing from one event to the other. Events provide a basis for measuring the program. Every event is represented by a circle, like I told you, and every activity by the arrow. Each event indicates initiation or termination of an activity. A sequential arrangement of activities is decided in such a way that a particular event cannot be performed without completing the preceding events. So first you'll have to complete the preceding events, then only you can go to the succeeding ones. Activities are arranged in a logical sequence and the order in which they are to be performed is already decided. A correct estimate is made of time to be taken by each activity. 3 time estimates are made: optimistic time, that shows the minimum time required if everything goes exceptionally well; pessimistic time, showing the maximum time of activity; and the most probable one, which lies in between the two. And what happens? The last step is to determine the critical path. Now, what is the critical path? It is the longest path in the network in terms of the time. If activities on this path are not completed in time, the entire project will get delayed. So it is critical because the time spent on the activities that lie along this path determines the total time taken in completing the project. Since all other paths are shorter, they have some slack time as well. So these are the this is how a PERT network looks like for a 7-month project with 5 milestones and 6 activities A to F. Now, like I told you, events and activities. What is a PERT event? A point that marks the start or completion of one or more activities. It consumes no time and uses no resources. When it marks the completion of one or more activities, it is not reached until all the activities leading to that event has been completed. Predecessor event. An event that immediately precedes some other event without any other events intervening. An event can have multiple predecessor events and can be predecessor of multiple events. Successor events. An event that immediately follows some other event without any other intervening events. An event can have multiple successor events and can be successor of multiple events. Besides events, PERT also has activities and sub-activities. What are the activities? Like I've already discussed with you, the actual performance of a task which consumes time and require resources such as labor, material, space, machinery. It can be understood as representing the time, effort and resources required to move from one event to another. PERT activity cannot be performed until the predecessor event has already occurred. And then there are sub-activities. A PERT activity can be further decomposed into a set of sub-activities. For example, activity A1 can be decomposed into A1.1, 1.2, A1.3 and so on. Sub-activities have all the properties of activities. In particular, a sub-activity has predecessor or successor event just like an activity. A sub-activity can be decomposed again into fine-grained sub-activities. So these are all about the events and activities. So if we see in our chart, we can just see that so the nodes and the arrows, and within those nodes in the circles, that there are preceding events, there are succeeding events. Then we come to time. Now, like we discussed, optimistic time, pessimistic time, most likely time, and expected time. The minimum possible time required to accomplish an activity or path, assuming everything proceeds better than it's normally expected, is the optimistic time. Pessimistic time is the maximum possible time required to accomplish an activity, assuming everything goes wrong. Most likely time, the best estimate of time required to accomplish an activity or path, assuming everything proceeds as normal. Then expected time, the best estimate of time required to accomplish an activity or a path, accounting for the fact that things doesn't always proceed as normal. The implication being that the expected time is the average time the task would require if the task were repeated on a number of occasions, over an extended period of time. Now, what are the management tools? PERT supplies a number of tools for management with determination of concepts such as float or slack. I told you that there is slack. What is that? It is measure of excess time and resources available to complete a task. That is known as slack. It is the amount of time that a project task can be delayed without causing a delay in the subsequent tasks. That is a free float or the whole project, the total float. Positive slack would indicate ahead of schedule, negative slack would indicate behind the schedule, and zero slack would indicate it is on time or on schedule. Critical path, the longest possible continuous pathway taken from the initial event to the terminal event. It determines the total calendar time required for the project, and therefore any time delays along the critical path will delay the reaching of the terminal event by at least the same amount. Critical activity, an activity that has total float equal to 0. An activity with 0 free float is not necessarily on the critical path since its path may not be the longest. Lead time, the time by which a predecessor event must be completed in order to allow sufficient time for the activities that must elapse before a specific PERT event reaches its completion. Then lag time, the earliest time by which a successor event can follow a specific PERT event. Then fast tracking, performing more critical activities in parallel is fast tracking. Shortening duration of critical activities, crashing the critical path. Now, what are the implementations? The first step for scheduling the project is to determine the tasks that the project requires in the order in which they must be completed. The order may be easy to record for some tasks, like when building a house, the land must be graded before the foundation can be laid. While difficult for others, like there are 2 areas that need to be graded, but there are only enough bulldozers to do one. Additionally, the time estimates usually reflect the normal, non-rush time. Many a times, the time required to execute the task can be reduced for an additional cost or a reduction in the quality. We can take this example here and you'll be able to understand it much better. That let's say there are 7 tasks labeled from A to G. So there are some tasks that can be done concurrently, like A and B, while there are others cannot be done until the predecessor task is complete. C cannot begin up till A is completed. D cannot be can begin up till A is completed. E cannot begin up till B and C are completed, and so on. Also, each task has 3 time estimates you can see: optimistic time, normal time or most likely time, and the pessimistic time estimate. So the expected time is calculated by the formula of the optimistic time plus 4 times the normal time plus pessimistic time divided by 6. Now, once this step is completed, one can draw a Gantt chart or a network diagram with the nodes and arrows. For a Gantt chart, it is in a Microsoft project. You can see it here. The critical path is in red. The slack is in the black lines connected to non-critical activities. Since Saturday and Sunday are non-work days and are thus excluded from the schedule, some bars on the Gantt chart are longer if they cut through the weekend. So that's how the bar diagram becomes a little elongated. Now, a network diagram can be created by hand or by using diagram softwares. There are 2 types of network diagrams: activity on arrow AOA and activity on node AON. Activity on node diagrams are generally easier to create and interpret. To create an AON diagram, it is recommended to start with the node named start. The activity has a duration of 0. Then you draw each activity that does not have a predecessor activity, like A and B in our example, and connect them with an arrow from start to each node. Next, since both C and D list A as a predecessor activity, their nodes are drawn with arrows coming from A. Activity E is listed with B and C as predecessor activity, so node E is drawn with arrows coming from both B and C, signifying that E cannot begin until both B and C have completed. Activity F has D as a predecessor activity, so an arrow is drawn connecting the activities. Likewise, an arrow is drawn from E to G since there are no activities that come alter F or G. It is recommended to connect them to the node labeled finish. The next step would be to determine the critical path if any activities have a slack. The critical path is the path that takes the longest to complete. To determine the part times, add the task durations for available paths. Activities that have slack can be delayed without changing the overall time of the project. Slack is computed in one of the two ways, like slack is equal to LF minus EF. Slack is LS minus ES. Activities that are on the critical path have slack of 0. You can see this diagram here. So this is the start point. A and B both are starting from getting the node from start. Now D cannot be started up till A is completed. C cannot be started up till A is completed, right? Now B is the first activity here, and you can see that there is a path is in a red color. This is the critical path, right? And all these are leading to finish. So this is the way you can make a nodal chart. So this is a PERT diagram which is showing the critical path as well. So our critical path is going this way. Now what are the advantages? PERT chart explicitly defines and makes visible dependencies between the work breakdown structure, that is known as WBS. PERT facilitates identification of the critical path and makes this visible. PERT facilitates identification of early start, late start, and slack for each activity. PERT provides for potentially reduced project duration due to better understanding of dependencies, leading to improved overlapping of activities and tasks wherever feasible. The large amount of project data can be organized and presented in the diagram for use in the decision making. PERT can provide a probability of completing before a given time. All these are the advantages of PERT. Now we come to the disadvantages of PERT. So there can be potentially hundreds and thousands of activities and individual dependency relationships, right? So it would be very complex and difficult in that case. So PERT is not easily scalable for smaller projects also. The network charts tend to be large and unwieldy, requiring several pages to print and requiring specially sized paper. The lack of time frame on most PERT or CPM charts makes it harder to show status, although colors can help, like example specific color for specific completed objects. So these can be the disadvantages of PERT and CPM. Now, uncertainty in project scheduling. What happens during project executions? A real life project will never execute exactly as it was planned due to uncertainty. As we all know, there is always some uncertainty, and because of which the project may not be executed the same way we expected it. This can be due to ambiguity resulting from subjective estimates that are prone to human errors, or can be the result of variability arising from the unexpected events or risks. The main reason that PERT may provide inaccurate information about the project completion time is due to this schedule uncertainty. This inaccuracy may be large enough to render such estimates as not helpful. Also, one possible method to maximize solution robustness is to include safety in the baseline schedule in order to absorb the anticipated disruptions. This is called proactive scheduling. A pure proactive scheduling is utopia, incorporating safety in a baseline schedule which allows for every possible disruption would lead to a baseline schedule with a very large make span. A second approach, termed reactive scheduling, consists of defining a procedure to react to disruptions that cannot be absorbed by the baseline schedule. So, this was all about the uncertainty in project scheduling, which can lead to not so expected results from the project, and hence makes this the entire project a little critical. So this was all about pertinent CPM. Thank you so much for listening.